Our objective today is just going to be able to graph lines no matter what they look like. No matter how the equation is given us, we want to be able to graph the given lines. So, two forms that are quick and easy are y equals mx plus b. That's slope-intercept form. That's the one where we start at b, just alphabetically. That's your y-intercept. And then you use m as rise over run to get you where you need to go to the next point. Point line plane postulate in geometry, the T word, don't throw things, says through any 2 points, there's exactly one line. So if we have 2 points and we did them right, that's enough. That's it. The other form that you have, definitely learned over the years, is ax plus by equals c. And that's called standard form. Now that one, it's really easy to find the x and y intercepts, and those are the zeros. So for this one, we can just quickly figure out the 2 zeros and hopefully get 2 points to graph it. Technically, you can turn all of the equations we're going to look at today into either one of those all the time. But the problem is when you take extra steps to do something, you may make a mistake along the way. So we want to be able to graph both of these and know that we can get them to look like one of these 2 forms. So the first one up here is one of those 2 forms. That's a y equals mx plus b. And we just need to remember that b is called the y-intercept for a reason. It's going to cross the y-axis at that point. And then m is our slope, which is rise over 1. So that tells us where to go. So I see these don't have x's and y's. We need that. We know there's more than one way to graph. There's the Cartesian coordinate plane, which we usually graph on, but there's also the complex number plane. We're not going to graph imaginaries today. We're just going to stick with the old x and y. So where does this graph start? -4. So down 1, 2, 3, 4, because it's always on the y-axis. Do you remember how to use the slope to move it from there? Up 3 and over 2. By over, which way do you mean? Right, exactly. There's no negatives here, so we need to go up 3 and over 2. And technically, that would be enough. I don't really make straight lines very straight unless I get a couple of them, so I usually do that a couple of times. Use that slope to give me something to aim at. And then things go a little better. And you could use the slope backwards, too, to get some stuff on the left if you wanted to. So, whatever you need to do, you could go back 2 and down 3. But there you go. I mean, there's your line. So if it's y equals mx plus b, should be pretty quick and easy graphing. So help me out with y equals -1/4 x plus 8. What are we doing with that one? How? Start at 8 where? Yeah, y-intercept. Y-axis. Then what? How do you know down? It's negative. Now, maybe I want to go up 1 and left 4. Could I do that? You guys are saying go down 1 and to the right 4. What would happen if I went up 1 and left 4? It is the same thing. The negative, you just get to use it once. That's it. But most people learn it down 1 and right 1. And again, I want to give myself something to aim at so my line is reasonably straight. There it is. Y equals 5, 6x plus 7. What you doing? Going up 7? Then what? I can't go up 5. I'm going to be off my graph. I'm going to be off my graph. Yeah, you could use the slope backwards. You absolutely could. Or you could say, oh, I better go by 2s. But what you don't do is start making your own grid up there. You never do that on a test, ever. So we could go down 5, 1, 2, 3, 4, 5, and back 1, 2, 3, 4, 5, 6 to the left. want to use the negative 10 to 10 that we have sitting in front of us. Alrighty, we've got a 9 here for our x-intercept, which tells me, yeah, I'm either going to have to go by 2's or I'm going to have to make an adjustment here unless something works out nice. Does this slope work out nice for us? It does. Where do we go? Down 4 and right 7. And now we've used that negative 10 to 10 grid. So just because we see a high y-intercept value doesn't mean we're going to have to start thinking of ways around it. We may have a negative slope, and things will go just fine. Alrighty, that is not y equals mx plus b. Now, if we're good at it, we could make it y equals mx plus b, but again, there's a chance we might do something wrong. So instead, these are easiest to graph by finding the zeros. And when I teach Algebra 1, I teach this as the thumb method. Because what happens to something when you multiply it by 0? You get 0, it's gone. So if I put 0 in the x, I take my thumb and I cover up the x. That's not going to be there anymore. And then it says 2 times something is 6. What's that something? 3. I go over here and I see I have a 0 in the y. I take my thumb and I cover up the y. 3 times something is 6. What's that something? Very quick and easy way to graph. And you could also, once you have it drawn, realize, hey, my slope here, I could go down 3 into the right 2 and get a couple more points. Plus, if you're like me and you need a little help making something reasonably straight, you can always use that once you have that on. When do you have to be a little bit more careful? When there's negatives, when there's subtraction. So if x is 0, now it says negative 2 times something is 10. What's that something? Negative 5. This one, a little easier, because we take the negative in the whole thing. So 5 times something is 10. What's that something? 0, negative 5. 1, 2, 3, 4, 5, and 2, 0. Now that's spread a little bit wider apart. I might not need another one, but if I did, I'd just go up 5 and right 2. Farther apart the points are, the easier it is to try to get a reasonably straight line. Alrighty, down to this. Oh, I forgot to put x and y on that. I should always do that. Is that in slope intercept form or is that in standard form? It's standard form again. Yeah. So, well, why does this have a star by it? Because this is when people make mistakes. When there's negatives in 2 spots, that just seems to some reason just freak people out. So, covering up the x, negative 6 times something is 24. Negative 4, good. Negative 4. Y is gone. Negative 4 times something is 24. What's that something? Negative 6, yeah. So you'd be extra careful with the negatives. So 0, negative 4, and 6, 0. And again, those are pretty widely spread apart. So we can probably get a pretty good line with it. But you wouldn't have to. You could say, hey, I have to go up 4 and over 6 and get a point, or even use the back of the slope. Oh, I did positive 6. Thank you. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's what happens when I'm thinking ahead about some of them that I have on your worksheet for you. Stay focused, Cedar. All right. So next one, we're going to do this one with y equals mx plus b, or are we going to stick with standard form? Sure. I mean, 8 and 2 are nice numbers for 16, right? Okay, so covering up the x's, 2 times something, 16. What's the something? 8. 0 in the y's, cover it up. 8 times something is 16. What's the something? 0, 8, 2, 0. Spread pretty wide there. There we have it. So 2 major forms that we're looking at here. That's not it. Well, we just figure out how to move stuff around and make it. So the first thing I do when I look at this one is I think, you know what, if I move that y over, this would be in standard form and this would be really easy. But some people would look at that and say, ooh, if I move that 8 over, now it's y equals mx plus b. So, which way did you think? Do you prefer y equals mx plus b? How many people, if given the choice, would move the 8 over and do y equals mx plus b? Raise your hand. Well, by golly, let's do it that way. Move it over. So where do we go to graph that? -8, so go down 8. Then what? Down 2 and over 1, and I realize that's getting a little too close, so I could go left 1 and up 2 a couple of times. Give myself something to aim at, so that it's not such a horrible crooked line. Right? So use this little forwards and backwards. So yeah, you definitely could have subtracted y from both sides and found the zeros with standard form. We could do that too. Which brings me to this one. And I'm going to do that with this one. Here's why. Do you see how there's a negative in front of the y? Most common mistake made in math is when you mess with negatives. So with this one, I'm going to go ahead and add y to both sides. If you know your weaknesses, you try to avoid them. That's just what you do. And that's in standard form. And we've got some pretty easy numbers to deal with here. So if 3x is gone, something has to equal 6. Well, that's going to be 6. And if the y's are gone, well, 3 times something has to equal 6. What's that something? Maybe 2. 0, 6, and 2, 0. There it is. Now, it wouldn't be wrong to subtract the 6 and then divide by -1. But 23 years of doing this and all the math learning I did in high school and outside of high school tell me that if we're dividing by a negative, we might make a mistake. It's just one of those things. So now, that looks interesting. So I think 2 things. If I subtract the 5y from both sides, -2 and -5 both go into 20, really sweet. So this would be a nice standard form equation. If I were to try to get y by itself, I have to add the 20 and then I have to divide by 5, and that's 2 steps. I might mess up. Well, the more steps I have, so I think I'm just going to subtract the 5y from both sides. So minus 2x minus 5y equals -20. Careful not to lose that negative. But it does have negatives, so we have to be a little extra careful. Well, we cover up the x. -5 times something equals -20. What's the something? Help out, please. Or if y is 0, this is gone. -2 times something is -20. What's the something? 10. So 0, 4, and 10, 0. That's a pretty good spread. Be careful on the aim halfway decent. Should be okay with that. Now, you'll get the exact same graph if you do solve it for y. It's just limit the amount of steps that you so that you don't accidentally mess up. All right, this one we will vote. Do you want it in slope-intercept, y equals mx plus b? Raise your hand if you want y equals mx plus b for this one. Seems like a reasonable request. Why? Yeah, all you have to do is divide by 7. I mean, that's not going to be bad. Of course, we'll move this around, so it'll be mx plus b. But yeah, that's reasonable. Not a lot of negatives or anything. So where does this one start? At 2. Where do we go from there? Up 3 and over 1. Do that a couple of times. Maybe go back to the left 1 and down 3. Give yourself something to aim at. Looking good. So we have 2 forms that we like because they are good for quick graphs. That's going to be slope-intercept and standard form. And you're going to get a worksheet, and it's going to be totally up to you what you want to do with them. So if they don't seem to fit one of these patterns, and you know you are super good at y equals mx plus b, then you just get them all be y equals mx plus b. If you have a little practice at both of them, you start thinking, okay, which one would be good for slope-intercept and which one would be good for standard form. That's really the thinking you need as you go into college algebra or pre-calculus, is to start thinking, what's the best method to use as I go through this? Then there's going to be some sneaky ones on your worksheet that are supposed to be easy, but we overthink them. What does the line y equals 1 look like? It is a horizontal line. Remember, it gets its name, y equals, because it karate chops that y-axis. So this would be a horizontal line. And then obviously x equals something will give you a vertical line. So those, sometimes we start to overthink it. We just get messed up in that. But it sounds like you're going to do really well with this, right?
X equals something, that means like fine.
If x equals, then we're talking about vertical line because it's going to karate chop the x-axis. Yeah. Y equals karate chops the y-axis, x equals karate chops the x-axis. Yep. All right. Any of these you think I should make one more example of? Something you want to see? All good? All right.